Ganina wala rot. Balik tayo discuss. 15 minutes. Okay. Hi, good evening, everyone. Tonight we are going to talk about block shear. Block shear actually falls for the rupture failures ato ang steel design because mainly, of course, it deals with the connection area. So, diri dapita ato ang failure. This is the tearing out of the segment or block of material at the end member as shown here. Look at this, kaning shaded area, mo na siya nadilid, kani ang nalangkat. Now, we are going to analyze the shearing areas and the tension areas nga naa diri. Okay? Combination ni siya sa shear area and the tension area. Now, shear is represented by A and V. As we have learned in the past, ang shear na to, V ato ang gamit for shear. T, of course, for tension. Shearing happens kung sliding, di ba? So, parallel na siya sa atong force, which is P. And tension is katong nalangkat diri dapita. Alright? So, that's it for the analysis. Inani. Simple na siya nga. Okay. Alright? Now, next thing we should talk about is the pattern. There are patterns unsay mga may tabo if atong langkaton siya under block shear. Now, for plates, we have this. The common kung may tabuan is kaning tunga mo mabilin since na diya ato ang connection. No? But na cases nga naka-L ra siya. Paglangkat kani ang tibok dako mo nabilin. And on the other hand, sa taas pabor. Same thing if naka 9 volts, 9 mega volts, the same thing. For angle, bars, and web of a T, inani iyang failure. So, ang pinaka-common ng mitabo is inani, kung one single line lang, dili siya pwede sa taas. Kaya naaman niya siya i-flange sa taas. And sa tunga, kung duwa ka layer, pwede po siyang tunga ra or pare sa taas nga tibuo. Web of an eye shape, so kanilang tunga. Dili pwede kang matir din sa lalong, kaya may flange. Same thing here. And lastly, for flanges, pare-pare sa plate but never ang tunga nga malangkat. Kaya na ay web diha. Kani ang nasa taas ha? Top view na siya sa itong eye. Now, to analyze eye is, kanina mo i-analyze, kanina usa, and i-multiply rin mo siya 4. Anong 4 man, sir? Siyempre, naman po yung flange sa lalong. Diba? If tira na siya, pwede rin po kanarang duha. Kung sa yung analysis, ani is multiply rin mo siya. O 4 or 2. Okay. Now, for block shear, we are actually going to use this formula. Nominal strength is 0.6 FUAND plus UBS FUAND. Dali rin na siya memorized. Why? It's because FA naman siya gyapon. Gikan ratanan siya sa stress ra gyapon. We had, diba? Load is equal to stress times area. More na. And gitauran na siya na 2.6. This is the block shear factor. Fixed na siya. Unsa rin UBS, sir? Well, ato na siya discuss on later on. Now, for the maximum nominal strength, kani atong comparison. Duha basically ato isolve. I-compare ni sila duha. The nominal strength, basically same formula, but you're going to use the yielding stress instead times its area gross. Kaning duha, i-compare nimo and we are going to use the smaller value. Giingon dire, dapat dili ka mulapaw sa yielding. Di na rupture yielding na if ever. And if mo fail siya dire, so kana atong gamiton. Okay? So use this smaller value. A and V is the net shearing area. Kato kung ipakita ninyo. Kani, address kilid. And AGV is basically katulad yapon nga part, A and V, but wala din mo siya minasan og whole. And we have A and T, the net tensile stress. Now, kato UBS, imong yung na sir. Our UBS na to is 1 in most cases. 1 atong gamiton. With them na siya og FUANT lang. Ang 0.5 man god, we use that for cope beams. Unsa din yung cope beam, sirs? Kanang cope beam na ay tendency nga atong ikat og tuyo ang atong wide flange. Ato siyang putlon inani to fit another wide flange or to fit another beam ato ibutang for design purposes inana. Unsa itsura in real life, sir? Inani siya. So na siya insert there. Oh, additional connection syempre i-weld mo na dito. Wala siya gipato totally. But na siya murag mo lock siya. Diba? Na-gets ninyo? Mas nindot po dyan connection. So 0.5 yung gamitin. Don't worry, i-state ko na siya sa problem. Now, for the hold on ha. Okay, it's good. If we are going to solve it for LRFD, kung unsa inyo na-solve nga nominal strength, i-multiply niyo na sa factor na 0.75. That is for LRFD, 0.75. And for ASD, i-divide that to atong nominal strength. Okay? Alright. Sige. Let's try to solve one problem. Actually, two akong i-prepare. So, let's try to solve a problem para mas ma-apply na to atong na-learn karon. Dali ra kayo gito siya. Okay. The nominal strength tension is given by this equation. Kanya akong isulti ganina. 0.6 FU/ANV plus UBS FU/ANT. Dali ra kayo memorize so. And use the smaller value again. Alright. So, question is, determine the block shear strength of a tension member shown. The holes are 22 mm bolts with holes 3 mm larger than the bolt diameter. Given ang FU and F1. Use 76 by 76 9.5 nga angle bar. And solve for ASD and LRFD. Before we solve, we need to write down the given sa mga given nga wala directly og ingon. Number one, nato masolve ani is ang diameter hole. We need to always to get diameter hole. Nga 22 mm bolts man ano. And it says there nga ang holes are 3 mm larger. So, by adding 22 plus 3, we have 25 mm diameter holes. Sa muna siya diameter aning circle dere. Okay? And given sa ato ang mga distances. Notice nga atong distance is from the center to the edge. 37.5 to the center. Importante na ang center to center siya. Okay? Now, next is we are going to solve for the area cross. Asa gatong area cross? Kung muna atong shear, dere P, ang area cross nato is here. Parallel sa imong load. So, ato pa, kaning tibuok. Pila din yung tibuok? Ang tibuok is basically the thickness na 9.5 times its total length. Kuto ba aray dari kapita? 37.5 plus 80 plus 80, that is 197.5. Multiplying, you'll get this value here. Now, for A and B, the same formula. But, minusan mo siya o diameter sa hole. Natay diameter hole nga 25, di ba? Pila ka buok bangag. We have 1, 2, and a half. 1/2 running dire. Wala siya mo lusot dire. Sa to pa, 2.5 ka buok, 25. So that means to say, 9.5 na thickness times 197 man tong tipo, 0.5. Minus na yun mo, 2.5 ka 25. You'll get this value. Do the same thing with the tension. Ang 9.5 thickness times 37.5 man yung tipo, minus na mo katunga sa diameter hole. That's why 37.5 minus 0.5, 25. You'll get this. Now, once you have this, kung yung pinaka-basic lang yun, itaod na nimo na sa formula. Block shear actually is one of the easiest niya masolve nimo. Taod na nimo na siya 0.6 FU/ANV, UBS FU/ANT. Once you have that, you'll get these values here, 483.36 kilonewton. Now, we are going to solve for the yielding na po. Substituting values, you'll solve for 404.85. Compare this. Asay mas gamay? Yes. Kani siya ang mas gamay. 404. So, we use the nominal strength na 404.85. Use the smaller value. For ASD, divided by 2, you'll get 202. That is now our allowable strength. And for LRFD times 0.75, you will get our ultimate strength, which is 303.64. Okay? Okay. Let's go to another problem. Same area po na siyang solution, but with a more twist sa itong ko. Now, compute for the block shear strength of the tension member as shown. Ang given na niya is the holes for the diameter bolts, which is 7/8 inch. And A36 is used. Kana ando ang given. Now, kung kana ra, we need to solve for DH first, the diameter hole, given ang mga distances here. So, ang diameter sa atong hole is, akong giingon ninyo is 3.2 man na i-add ninyo sa diameter sa bolt, 3.2 mm. Now, since English ni, kanang 3.2 is actually 1/8 na siya. Sa ato pa, ang diameter sa hole is 7/8 inch plus 1/8. That is DH. Okay? And we use A36. Wala siya gibutag FY o FU. Pero ka-memorize na ta dapat ani. FY is 36, FU is 58. Ato ang kuan kay A36 man. Now, another thing you have to notice is natawa 2 inches ang gihatag niya from flange to the center. Nya ang atong i-analyze ra ba ang lalom kani nga width. Pila man day ni? Makuha na to na kay since we have na 3 and a half times 3 and a half times 3/8 ang ato ang angle bar. Sa ato pa 3 and a half din tibuok 3.5. Nya to man nas taas sa ato pa 1.5 na lang ni. 1.5 ni. Muna siya itong mga hidden given. Wala gi directly butang diya. But you can solve for it. Now, for the shear areas, let's solve for AGB first at tibuok. So, makuha man nato ng tibuok, di ba? Kay, we have a thickness nga 3/8 times. Pila din yung tibuok? Pila din tibuok? That is 1 and a half plus 3 plus 3. That is 7.5. You will get 2.813. Now, ato tas A and B, doing what I did before, we have 2.5 kabuok holes. 0.5 running. Times sana nimo sa diameter sa hole, which is 7/8 plus 1/8 as I have said. So 2.5. Minus sana siya sa 7.5. Of course, 7.5 lang tibo. You will get 1.875. Now, for the tension area, do the same. 0.5 lang ni. And you'll get these values here. Ultimately, you have to substitute here. And then once you get the answer, we have 87 kips. Compare it to the upper limit, which is atong yielding, and you'll get 82.51. Kisa atong gamiton sa duha? Yes, si 82.51. That is why 82.51 times ato ang LRT factor 0.75, 61.9 ang magawas. Divided by 2, you'll get 41.3. Mao ni ato ang answers. So that's it for block shear.